In this question, we are asked, what is the pOH of a 120 milliliter solution that contains 3 grams of lithium hydroxide? So we dissolve 3 grams of lithium hydroxide into a 120 milliliter solution. We want to find out what the pOH is. When we're calculating pOH is going to be equal to the negative log of the hydroxide ion concentration. So we want to know what hydroxide ion concentration is. Now, we're not told hydroxide ion concentration in here directly, but lithium hydroxide has the formula of LiOH. So the concentration of the lithium hydroxide, the concentration of the hydroxide ions will be the same. You do need to be careful about this. Not every base has the same concentration for the original compound and the hydroxide ions. If there is more than one hydroxide ion in the base, the concentration will increase proportionally. So if you have a base that has a concentration or has 2 hydroxide ions in it, the concentration of the hydroxide ions will be double the concentration of the base. But in this case, it's a 1-to-1 ratio, so they are going to be equal to each other. We are told that the volume of this solution is 120 milliliters, that it contains a mass of 3 grams of lithium hydroxide, and we can calculate that the molar mass of the lithium hydroxide from our periodic table is 23 and 95 hundredths of a gram per mole. Now, we want to find moles per liter, so we're going to swap over our volume into 0.120 liters instead of using milliliters so that we get the correct units. Okay, we are going to start with some unit canceling to figure out what the concentration of the hydroxide ions is. I want moles per liter in the end. I have moles already. So I'm going to flip my molar mass upside down. For liters, I have that too. I want to put liters onto the bottom because I want them to be on the bottom of the fraction in my final units. And then I need to cancel out grams. I can put those grams up top because the grams I want to get rid of are on the bottom. This is going to give us a concentration of 1.04 moles per liter. And this is the concentration of both the lithium hydroxide and the hydroxide ions. Now, we are going to use this number in our next step to calculate the pOH. pOH is the negative log of the hydroxide ions concentration. So that means it will be the negative log of 1.04 moles per liter. Now, that moles per liter is going to disappear. pH and pOH do not have units to them. They technically do, but we never record them because those units have had the logarithm function applied to them and saying the log of moles or the negative log of moles over the negative log of liters is both a handful or is a mouthful, and it doesn't make intuitive sense. So we don't usually write the units down for these. This is going to give us a pOH of negative 0.02. And there's two things that I would need to point out with this answer. First off, it has a 0 in front of it. Okay? Now, normally zeros in front, we don't count as being significant. But the point where we start counting significance when we deal with logarithms is our decimal point. So even though both of the first two numbers are 0, we do actually count a 0 and a 2 as being significant digits here. The other thing is that this is a negative number. The pH and pOH scales do go into the negatives. Because the concentration of this solution is greater than 1 mole per liter, the pOH of it is actually a negative number because we took the negative logarithm, and the log of 10 is 0. Or sorry, the log of 1 is 0. So as soon as you go above 1 mole per liter concentration, you start to get negative pHs and negative pOHs.